Thank you for having me, Australia. This is my third time, and I really loved here. You guys have awesome weather and awesome beers, New Zealand in particular. All right, I'm going to talk about what JRuby was last year, and what is going to come this year. Have you heard of JRuby? Great, great. Have you tried JRuby? All right, great, good amount. Are you using JRuby? Oh, okay. I would like to convince you that JRuby is worth a try, and there are some major pain points that you are aware of that is keeping you from trying or using JRuby right now, and I would like to present some of the ways that you can mitigate those pain points. Before going over those points, I would like to remind you that JRuby is an implementation of the Ruby language, yes? And at the end of the day, JRuby really wants to be just Ruby for you, all right? But of course, there are differences, and I don't want to pit the two implementations as rivals, but they are different, and differences can work for your advantage. And there are some things that are fundamentally different, and there are no ways of getting around those things, and that is threads. In the days of Ruby 1.8, there was only one thread for the Ruby interpreter that can be used. And threads, as implemented by the Ruby runtime, was just one single thread on the OS side. In Ruby 1.9 and 2.0 and 2.1.2, things improved slightly in that Ruby interpreters can now use more than one OS threads, but there is a global interpreter lock that prevents those threads from running concurrently. If you have a very busy Ruby process, you will see only one core being busy at all times, even if you had quad-core, 6-core, 8-core machines, 32 cores on the big server. And JRuby, threads are backed by OS threads, and you can use many cores at once. And that is one possible reason that you want to look at JRuby instead of MRI for your application. So I would like to say that JRuby is really a fast implementation of the Ruby language on the Java virtual machine. Java virtual machine is a specification, and as long as you are running on the machine that conforms to those specifications, JRuby is theoretically be able to run your code. There are more than one Java virtual machine implementations, believe it or not. There used to be JRocket by Oracle, J9 by IBM, and I believe Harmony by Apache. I don't know the various details of the implementation at this point, but one thing we can tell you is that JRuby improves just by the implementation's improvements over time. We're going to get back to that in a minute. But another reason that JRuby can be fast is the faster and more mature garbage collectors. I use the collectors, plural, because on the OpenJDK, which is the reference implementation of the specification, has more than one garbage collector. generational ones and the newer G1 collector and so on. If one doesn't work for you, you can try using other garbage collectors. Here's a graph that will show you how JRuby's garbage collector is, or I should say JVM's garbage collector is superior to Ruby's. You can see that as the memory consumption grows, Ruby's garbage collector takes more time per garbage collection to clean up the garbage. Right? That's pretty straightforward, right? Now here's a benchmark of a computing Mandelbrot set on the JRuby plotted against MRIs. MRI is pretty fast here because JRuby is just doing the interpretation of the program. Okay, there is nothing that JRuby does to optimize the code, the Ruby code that is getting passed to the JRuby runtime. Things can improve if you implement some tricks on JRuby side, and that is to use the JIT compiler that comes with the JRuby runtime. Okay, it's about half the speed, or twice as fast on the compiled AST as Ruby 2.1. The x-axis is just the 20 runs of the same benchmark. Okay? Okay, looking at the web server side, because many of you are Ruby, Rails programmers, I assume. Yes? And looking at the JRuby side, moving to JRuby may require some change in web servers, because we have different set of web servers available. One is called Torquebox. This one is backed by JBoss server, and it has application server along with all the services that you might like, messaging, job scheduling, and so on. Another one is Puma, written by Evan Phoenix. And finally, Trinidad, which is based on Tomcat server. Torquebox is one that is built by Red Hat. As I said, it has messaging, scheduling, caching, and daemons all wrapped up in one, so that you don't have to worry about setting up, for example, delay jobs or crons or things of that nature. And you can just mash up, put together everything in one place and forget about the setting up other services. Okay. Puma is another one. I don't have personal experience with Puma, but I believe this one works with Rubinius as well as MRI. And if you are looking at the changes to JRuby, this might be the one you might want to look at first. Finally, Trinidad is based on Tomcat, and it's very lightweight. It's very similar in use to the what's a web server that came before it? WebRick? No, not the WebRick, but the other one. Mongrel? Mongrel. It's very simple. It's not as fast as Torquebox. We're going to look at the performance of these things in a minute, but Trinidad is something you can look at in the beginning, just as Puma. And on the deployment side for your web applications, you have Heroku, OpenShift, and you can do your own thing with EC2. Okay, let's look at the website benchmarks. There's this thing called Tech Empower benchmarks. And the latest round, 8, came December last year. And it will pit Ruby 2.0.0 and Unicorn against JRuby 1.7.8 with Torquebox, I believe 3.0. So let's look at the first benchmark. JSON serialization and peak responses per second. Depending on what web framework you use, the numbers vary. Across the board, except Sinatra, JRuby is faster than Ruby 2.0.0. And this is the same graph in log scale so that you can see the numbers slightly better on the lower end. You can see that Rails is slightly faster than Sinatra, which might be surprising in some ways. The next benchmark, whoa, what happened there? Ooh, what did I do? Okay, let's try again. No. Okay. Okay. Next one. Look at the single query database query. Single response, and higher is better here. And you can see that JRuby outperforms Ruby 2.0. We don't have the data for 2.1 yet because round 8 didn't include it. All right, here's another one. Multiple queries. JRuby is massively faster than Ruby 2.0. I don't know how much is JRuby's contribution and how much is Torquebox, but 2.0 is using Unicorn. So you might want to try your own benchmarks to do that. Okay. All right, let's look at the history of JRuby. JRuby is surprisingly young. 2001 started by a German programmer named Jan Arne Petersen. I have never met him. I would like to give him a hug. But he started the project at 2006. Rails support came along. And this is around the time when Charles Nutter and Tom Enable, the current co-leads of the project, joined the project to make it massively better. 2011, we had 1.6.0, which included experimental C extension support, which I will talk about in a minute. And 2012, we had version 1.7.0, which included InvokeDynamic support, which also I will talk about in a minute. In particular, last year, we released 1.6.8, which is probably going to be the last of the 1.6 release. If you are still on 1.6, please consider moving up to 1.7 because it's massively better. And we released 1.7.2 through 1.7.9 last year. And 1.7.4 introduced Ruby 2.0 support, which is still considered experimental. And we branched 1.7 development so that we can forge on to the next and best JRuby ever. We had 2,459 commits in the master branch, and 1,939 commits on the 1.7 branch. And the split happened on October 1st, and Tom is a little incredulous about the state of the future, but it should be now, exclamation point instead. Okay, there are many ways JRuby can still be better, and in order to understand how that can happen, we need to understand what JRuby is made of. And here's a big enterprise slide. You can see the JVM at the very bottom. On top of that, we have JDK, and Java libraries. On top of it, we have JRuby core classes and compilers, and then Ruby after that. Okay? Your application will be sitting on top. So let's look at what JVM what JVM improvements will bring us. JVM is constantly evolving, and without JRuby team doing any work at all, JRuby can get faster because JVM becomes faster. Over time, you can see that the red-black tree benchmark, micro benchmark, will improve as Java improves, 1.4 to Java 5 to 6 and 7. In comparison, in that time, MRI's performance stay constant, of course, because it has nothing to do with Java. And you can see that JRuby beats it just because it runs on a better Java runtime. And there is a new feature in Java 7 called InvokeDynamic, which is a bytecode, a new bytecode to the Java virtual machine that will speed up the invocation of dynamic language calls. Not just for JRuby, but for Jython, Scala, and Clojure, and others. And in theory, this is what Charlie tells me, and I believe what he says when he comes to JRuby, Java stuff. And JRuby can be as fast as Java, in theory. But InvokeDynamic did have some problems in the initial release. There were some bugs, at least on the first update and second one. And it was rewritten for the update 40, and the latest version of Java 7 is update 51, and it should be pretty stable at this point. But Java forges on, and Java 8 is due out next month. And InvokeDynamic should be pretty stable here. However, the performance is not that great. You can see the 20 invocations of the same Mandelbrot micro benchmark that I showed earlier. The blue line is Java 7, and green line is Java 8. Beta 128 is considered to be release candidate. It won't be significantly different from the one that is going to be released next month. It's slightly faster, but not by much. So how can we make JRuby better? There was another one, another component called following function interface that Zach earlier showed us. And that's where things can improve for JRuby as well. FFI is a Ruby gem available for both MRI and JRuby. FFI comes bundled with JRuby, and it allows you to call the native functions from Ruby code just like that. Okay? And FFI, whoa, I did it again, I'm sorry. FFI might come in Java 9, which is scheduled to be released in 2016. It might, because it's still in JEP stage, that I believe is Java Enhancement proposal. And Charlie Snutter, who is the co-lead of the JRuby project, has put forth a proposal so that this can be incorporated into JDK and become faster and better over time. All right. So please raise your hands again if you're using JRuby now. All right. So when I say this, I think you will agree with me that startup times is a major, major pain point for you. Yes? Yes, great. Because a lot of things that JRuby has to do when it starts up is not something that you or I or Charlie can fix, really. Because JVM has to warm up and JRuby has to wait for those warm-up things to happen before we can start running your code. And here I am going to compare the startup times between 2.0 and JRuby. If you just run E1, that means what? Execute the statement 1 and gem help and run rake-t. I believe this is just the Rails app to list all the rake tasks that are defined for the Rails application. You can see it's, let's see, 2.5, right? So it's about 1 second max for MRI. For JRuby, it's forever. Okay, so there are things that you can do without doing anything else on the JVM. There are tuning possibilities that you can use. Oops, I forgot to change the slide order. I'm going to get to the optimization tuning parameters later then. And there are other utilities that you can use to help this painful startup time. First one is called Nailgun. It is bundled with JRuby distribution, so with very small change on your workflow, you might be able to take advantage of that. Did it again, I'm sorry. Nailgun is let's see, it is a server, client, and a protocol all in one package that will keep a single JVM running in the background warm so that when you call your JRuby process next time, it is going to talk to the server to fetch the result, right? So you're going to run the code, but the server is going to run the code and keep your JVM warm. You ask for the server to run this code, and you're going to get the results back. There are bad things about this setup, because if you have a warm JVM, you might have something you don't want in that, right? So if you are, if your application is dependent on those things, you might get some erroneous results that you don't want. Let's see. Okay, and since we are talking to the server over a protocol, you might not get the terminal that you want in your user's process. Okay, there's another way to do it. It's called drip. The way it works is that it is going to start a new JVM every time you execute something. It is going to start a JVM, and at the same time, it is going to boot up a new JVM so that next time you call the JRuby command, it will be called against the JVM that is already warm. Okay? It takes more memory, but it might be good for you. All right? And let's see. Okay. And so how does this affect the startup time? Let's see. This is just running 20 invocations of rake-t against this simple Rails app from scratch with a Postgres adapter. And the green, in general, the green lines are for Java 7, red lines are for Java 8. Light colors are no optimizations, and the dark ones have optimizations that I'm going to talk about a little bit in the next slide. And the solid lines are for no drip, and the dashed lines have drip used. Right? So you can see that for this benchmark, using drip, Java 7, and the optimization flags will yield the best results. So what is the optimization that you can use? And it's here. You want to use a different compilation strategy, and you skip the Java class file verification stage. You don't need to do that when you're just trying to run your tests, so that you can start up as soon as you can. Okay? There's more. You can do a little more optimization for the startup time with drip. Recall that drip allows you to execute extra code when you pre-boot the JVM. In order to take advantage of that, JRuby will give you some of that code built in. What happens here is that basically you want to instantiate a JRuby runtime and warm up the JVM that you want, and then look for the, oh, no, not yet. Define the pre-boot file and instantiate a Ruby runtime here and read the content of that file, if there is one, and go on its merry way. If you use that strategy, you can beat JRuby's startup time with rake-t. We're cheating a little bit. You understand that, right? We're not really beating it, but we are just booting the JRuby runtime ahead of time to do most of the work, and then start your command next, so that you can get to run your Ruby code fast when you want it most. Okay? So that's something that you might want to take a look at if you want to run the tests or things of that nature. Okay. Then what comes in the next generation of Ruby? In 2014, we intend to release version 9000. And you might ask, why 9000? It's a great, great number, right? It's obviously better. On the 12th year, we are going to beat MRI's version by 9000, basically. Yay. But why 9000? No, audio. Okay, I have to do this again. I'm sorry. All right, let's do this again. Oop.
Vegeta, what does the scouter say about his power level? It's over 9,000!
Over 9,000, right? But we are going to release version 9,000. Charlie's joke is that he wants to release the next one so that he can use this joke. But if you are familiar with the Dragon Ball Z, I'm sorry, in the first place, you should listen to this video instead. That's right. In Japanese and the original version, everywhere else but English-speaking world, it is 8,000. So, just by releasing 9,000, we already achieved the goal that we want. Okay, so there are other things that are happening in JRuby's architecture. And remember the part here, interpreter, and that part had the compiler and bytecode backend in the previous slide. I'm sorry I didn't change that. But that part can also be improved. And the first one is called intermediate representation, IR for short. And what happens is that right now we are just building an abstract syntax tree by looking at how the code is Ruby code is laid out and building the tree and executing that right now. And as the time goes on, we are going to compile that AST into something that JVM can execute faster. But we can help JVM by doing more work up front, and that is what IR tries to do. Instead of lexical analysis, we want to do semantic analysis and build control flow graphs and data flow graphs and do the optimization up front. The beauty of it is that from the IR instructions, you can interpret or generate bytecode or generate Davlik code so that Android devices can execute the bytecode faster. This is a little complicated, but by looking at the code here, IR compiler will see that there are a lot of dead code here. Parameter B is not used. C is assigned the constant value 1, and the last assignment D equals A plus C is basically a dead code. So at the end of the day, it will reduce the code to something like that on the right side. Who of A, although B is still required, it just returns A plus 1 instead. Okay. IR is not the only compiler that is going to be replacing the compiler part. There is one called Truffle, and this is coming from Oracle Labs, and it shows some promises. And let's see, the green light, that's on par with the compiled AST part right now. It's still considered experimental. And with the help of the JVM level improvement, it can still do better, slightly, right? On the mandible set benchmark. But here, the work still remains. The part that is hard is getting the code that you want to run correctly and faster. the truffle and IR had some promises, but it still needs some work in terms of correctness. And finally, we're going to look at what Ruby layer will look like in the JRuby 9000. And it is going to be 2.1 compatible. And there is no plan to support 2.0 at this point. There are limited supports on the 1.7 branch, as I mentioned before, but we're not going to work on that because 1.7 at this point is just maintenance now. Okay? And 2.1 specs are still incomplete, and if you're willing and to help, we are more than welcome. You're more than welcome to join the effort. C extensions are no more because we had some problems. It was an incredibly brave effort to support that, and it was a great thing on the team. But it was slow to execute because global interpreter lock still needed to be maintained, and that put a lot of unfair penalty on the C extension code. And finally, in this year, for the third year in a row, JRuby team has applied to be the mentoring organization for Google Summer of Code. If you or someone you know are interested in participating as either mentor or as a student, please get in touch with us. I have stickers, JRuby stickers, so if you want them, just grab me afterwards. Thank you.